You might be familiar with this identity. Sine squared x plus cosine squared x is equal to 1, no matter what x is equal to. That's the Pythagorean identity, a very well-known identity in trigonometry. Now, have you ever considered this one? Sine inverse of x plus cosine inverse of x is equal to pi over 2, no matter what x is, as long as it's in the domains of sine inverse and cosine inverse, if you just want to deal with real numbers. So over here, this one's actually true. However, I'm assuming this one is way less well known than this one. So if you're not familiar with it, don't worry. In this video, I'm going to focus on proving this identity. To start, we're going to let sine inverse of x be equal to theta. Now we can isolate for x if we take the sine of both sides. Then we would get x is equal to sine of theta. Now, we can now consider cosine inverse of x. Cosine inverse of x, this over here, well, if we replace x with sine theta, we get cosine inverse of sine theta. Now, the simplification here might not be entirely obvious. I mean, there's a cosine inverse and a sine here, so what do we even do? Well, if you recall the identity, sine theta, this is equal to cosine of pi over 2 minus theta, right? So if we use this identity, we can actually replace sine theta with cosine of pi over 2 minus theta, right? So we get cosine inverse of cosine of pi over 2 minus theta. Now, it might be tempting just to immediately cancel out the cosine inverse and cosine, but be careful. If you recall, the range of cosine is actually 0 to pi inclusive. Now, given that this range is true, we notice that there's a problem if we directly cancel out cosine inverse and cosine. If we cancel them out, we would only get pi over 2 minus theta. And if pi over 2 minus theta happens to be outside of this range, then that's a problem because this is literally the range of cosine inverse. So it can't be outside of this. So to formally cancel out the cosine inverse and cosine, we need to show that this will always be within this range. Thankfully, we can do that. Consider our very first let statement. Let theta equals the sine inverse of x. If you recall, the range for sine inverse of x is from negative pi over 2 to pi over 2, inclusive. Now, think about it. If theta were to be equal to pi over 2, the maximum, then over here we would get pi over 2 minus pi over 2. That's 0. Good, that's in the range. And if theta was equal to the minimum value, negative pi over 2, then over here we would get pi over 2 plus pi over 2, right? And that's just pi inside. So pi is also within the interval. Now, notice that we've considered the minimum and maximum value, and no matter what, we see that this will always be within this range. That's good for us. This means we can always cancel out the cosine. So we're only left with pi over 2 minus theta. There we go. Now, pi over 2 minus theta is much more easier to work with. Consider this now. Sine inverse of x, this was equal to theta. And if we add cosine inverse of x, which is equal to which is equal to pi over 2 minus theta, right? Pi over 2 minus theta, then theta minus theta is 0. And we've proven the identity. The result is just pi over 2. And that's it. So yeah, that's a new trigonometric identity if you weren't familiar with that in the past. So that's it for this video. I hope you learned something new, found this interesting. If you did, then please do consider dropping a like and subscribing. Thank you very much.